All right. Well, in the interest of time, we'll go ahead and get started. Thanks everyone for joining in for day 2 of this training about the Safety Analysis Guidebook for PD&E studies. And again, I'm Beth Wemple in Portland, Oregon. So if I keep referencing the wrong time zone, now you know why. I'm on Pacific time. And Rob, say good morning. I mean, good afternoon.
Good afternoon. Thank you all for joining us.
So today we're gonna there's 3 modules today, 2.5 really. The last module is just wrap up, so it's a little bit quicker. But today we're going to talk about the predictive method and how that can be integrated into alternatives evaluation for PD&E work. And then we're going to talk about module 6 is scoping and reviewing safety analysis. And in our eyes, this is kind of another sort of checklist sort of module to help you all think about or identify what you should be thinking about as you're scoping or reviewing a safety analysis. And then we'll go ahead and wrap things up. So let's go ahead and start diving in. This module, again, is about the predictive method. Like yesterday, we're not going to be teaching the method. I mean, we'll certainly overview it and explain some of the major concepts. But we're trying to make this about what you should be thinking about as you're doing your analysis or reviewing an analysis or doing QC or something like that. So we're going to provide an overview of the method. We're going to talk through the tools and resources, how to start interpreting results, and sticking with our theme, documentation, what you should be documenting in the method, so that, again, you get that transparency and it's somewhat reproducible. So at the end of the day, the predictive method, which is part C of the Highway Safety Manual, lets you estimate average crash frequency for facilities as a function of traffic volume and the roadway features. And so just for example, you could take these 2 cross sections on the left and right and estimate safety performance under option 1 over here on the left, estimate safety performance under option 2 on the right, and then compare and contrast safety performance, benefits and costs associated with safety, and then also how that does, or how, use safety then as an evaluation criteria alongside traffic operations, noise, all the other sort of normal stuff. So end of the day, you're estimating average crash frequency per year, and you're using traffic volume, which is ADT, and then the roadway features to make these estimates. So in a moment, I'm going to run through these, what I consider the sort of the 4 main pieces of the predictive method. But first, and perhaps true to form, we're going to start with a Mentimeter. And the question, oops, I'm going to get that into present mode. There we go. So I'll let you all sign in to Menti and add the code, and then tell us how familiar with the predictive method you are.
Yeah, just a reminder, if you either weren't with us yesterday, or so it wouldn't be a reminder, or if you were and you forgot, it's menti.com right there at the top of the screen, and that code, and you can do it on your computer, use on your phone, however is convenient. Like yesterday, we'll use it throughout. So and Beth gave you some great options for this question. The PDF does not make a great doorstop, though, I'll tell you.
I've also seen people using it for raising their computer monitors.
Yes, yeah, right.
All right, looks like it's sort of slowing down. So we've got folks who haven't used it, a handful that are sort of an equal amount who are at least familiar with the concept. We've got a handful of pros, so hopefully we'll give you some tips and some doorstops. Maybe for those of you that are using it as a doorstop, we can maybe get you sufficiently intrigued to open it up. And if you do open it up, or you're completely unfamiliar with it, a great place to start with it, honestly, is Chapter 3, Fundamentals. That like lays the groundwork for what you should know in order to use the manual, and that's not very long. So anyway, there's my plug for the manual.
Yeah, I'm gonna just jump in and say, and if so if you're, and we did this yesterday, who's kind of doing technical work, who's project manager, who's managing projects and all your roles, if your role is such that you wouldn't find yourself doing the work, it's still good to know what's in it to make sure that you're kind of asking the right questions and have the right expectations of folks. What are we able now to do with this method, to me, is an important thing for everyone to know the answer to. Oh, we can do this, maybe we can't do this yet. And just having an understanding so you can ask the right, sometimes tough questions of project teams.
Good points. So let's talk about the predictive method. There are sort of four main things involved in the predictive method. There's the safety performance functions, so the SPFs, the crash modification factors, CMFs, which, as I mentioned yesterday, are going to be called adjustment factors in the second edition. There's a calibration factor, and so this is just a modification to the prediction. And then there's the empirical Bayes when appropriate. So I'm going to talk through each of these now and hopefully kind of introduce the concepts. So these SPFs, the safety performance functions, they are specific to facility types and roadway segment and intersection types. And they're just regression equations developed from crash data and crashes in roadway and traffic volume data on specific facilities across the country. And in the manual, you'll find these equations for rural 2-lane highways, rural multi-lane highways, urban and suburban arterials, and then there's freeways and ramps. And then there's one-way roads, right? Is in the IHSDM.
Yes. Yep.
I feel like I'm overlooking something. Anyway, so there's these specific equations, and as I said, they're developed from research projects from across the country, and the output is crashes per year. And fundamentally, what you're doing is you're going to the manual and you're saying, I'm doing some work on urban and suburban arterial, shown here on the right, and 3T stands for 1 lane in each direction with one 2-way left turn lane. So that's my facility type, and here's my traffic volume, and it spits out some crashes per year. So that's kind of the basics of what you're doing. And the SPF reflects a base condition. Well, let me talk a little bit more about this. So this is what the SPFs look like. Here's an example for rural multi-lane divided highway, and here's the equation for it. And so there's some variables in here, and you're going to go to a table in the manual and you're going to pick up these variables and plug them into the equation. Now, in actuality, you're going to use a spreadsheet to do this for you. You're not going to do these lookups, but this is what's happening. There's also, for each equation in the manual, an over dispersion parameter, and I'll talk about this more in a moment. This is associated with the empirical Bayes method, but again, there's a variable that you're going to pick up from a table and plug into an equation and you'll use that for your K, your over dispersion parameter. And again, we'll circle back to that. So fundamentally, you're looking up an equation for a specific roadway segment or intersection type, and there's some variables in the manual to help you do it. And so that's what's called your baseline prediction. So that says for rural 2-lane highways, for example, with 12-foot lanes and 8-foot shoulders and this particular side slope and no lighting and all these different characteristics, that's a base prediction. Then the fact of the matter is, though, your facility is different from that somehow. Maybe instead of 12-foot lanes, you have 11-foot lanes. And maybe instead of paved shoulders, you have gravel shoulders. And maybe, strangely, you have lighting on your rural 2-lane road, whatever. So there are these adjustment factors, or CMFs, as they're called now, that modify that base prediction to reflect your local characteristics. And so that adjusts your prediction a little bit. And these adjustment factors, or CMFs as they're known now, they are different for each different SPF in the manual. Here I'm showing the adjustment factors for rural multi-lane undivided highway. So if the base condition is 12 feet, but my actual condition is 11, then there's a lookup table, set of tables or equations in the manual, but spreadsheets are doing this for you. There's an adjustment factor of 1.03, and so on for shoulder width and type and side slope, lighting, etc. So again, these base conditions are specific to the safety performance function, and you are the second step in this after you've picked your safety performance function, is you're applying all these adjustment factors to reflect your local road. Now the next step, so that's reflecting your local physical road, right? This next step is applying a calibration factor. And so this is to modify that base prediction to reflect things that can't be accounted for in the model. It could be weather conditions, it could be the way crashes are reported and recorded in California versus Florida. It could be driver behaviors, it could be driver demographics, but there's just differences. Every model requires a calibration factor. So what the calibration factor does is just modify this prediction up or down. It could be increasing it too, as a function of a comparison of observed crashes to predicted crashes. So the equation, the calibration equation, really is as simple as total observed over total predicted. And we've developed these calibration factors for other states. There's a lot that goes into it to get the database set up, but fundamentally, the calibration factor is as simple as this. And for Florida DOT, the calibration factors are on the HSM, your guys' HSM webpage. So that's an important step, right, to modify your local physical conditions to sort of the overall local characteristics, if you will. Now, this next step is kind of an optional one. When you can use the empirical Bayes method to, as we said yesterday, kind of do a weighting between your predicted crashes, those from this model that we just talked about, to observed crashes, to get this, as we were calling it, this weighting of what you would actually expect for facilities like this. And you do that by applying the empirical Bayes method, which sounds complicated, and the statistics behind it, I can't why it does what it does, I can't necessarily explain, but the equations are pretty simple. So you're just modifying your predicted crashes relative to your observed crashes as a function of this weighting factor developed through the over dispersion parameter. Now it sounds like a lot, And again, when you're applying the spreadsheets, spreadsheet's doing all of this for you, and you're getting your over dispersion parameter directly out of the manual. So the act of applying the EB is relatively easy. The tricky thing to keep in mind is, when do I use the EB? And I'm going to turn the slide so I don't speak over it. So the EB is applicable since you're combining predicted and observed crashes. It's applicable in conditions where you wouldn't expect observed crashes to change a lot from over time. So it's really valuable under an existing conditions scenario, or maybe a network screening scenario where you're trying to identify locations that might need safety improvements, because you're predicting crashes on your existing facility. You can use observed crashes from the existing facility to develop that blending and get that more rigorous expected crashes. So you can use it when you have safety performance function and a calibration factor. You have observed crashes, and the roadway geometry and traffic control are not changing very much between the no build and the alternatives. So we'll talk about that more. And the alignment isn't changing much, because again, you're relying on observed crashes as part of your weighting. And if the system's changing a whole lot, you wouldn't expect observed crashes to stay the same. So the empirical Bayes method can't be used or shouldn't be used if there's a substantial change in the system, if you don't have a calibration factor. So if there's a new alignment, you're not going to be using EB. If you're widening a project that changes the typical section dramatically, again, where you wouldn't expect observed crashes to stay the same, you're not going to use it. If you're changing an intersection with the number of legs or the type of control, you're not going to use it. So the question is, when are you using it? Well, you're definitely using it. You can be definitely using it in existing conditions. I'll say the potential for safety improvement, in case you haven't recognized a theme, or in a network screening exercise. So this takes us to another question, which I didn't need to do that. I needed to do this, which is doing this. So select all methods that apply. So identify the situations where the EB is applicable.
And I'm going to read it just in case you're having a hard time reading it. It's, the left is converting a 2-lane rural road to a 4-lane rural multi-lane highway, and changing a 4-leg all-way stop control to a signalized intersection. Middle one is widening the shoulder of a 2-lane rural highway from 6 to 8 feet, and adding an HOT lane to both directions of a freeway. And then there's the none and all categories. None of these, all of these. And I think, Beth, as we talk this through, there may be an added level of complexity that, you know, you're asking kind of the surface question, and there may be another way to interpret this question and answer it differently. Just thinking out loud here.
Oh, that's interesting. I haven't seen the complexity yet, so you'll have to tell us. Well, when we laid out the question, we definitely thought widening the shoulder. But Rob, why don't you tell me what you're seeing?
So on the surface, I think that to me that's the answer. And as you were talking before, I was just reminded of prior discussions about this and writing the manual and everything, that EB doesn't have a lot of applicability to
Right.
a typical PD&E study or project, because usually what we're doing is something more substantial. And it's not, so it clearly does apply to a shoulder widening project. But you look at some of the others, changing a 2-lane rural road to a 4-lane rural multi-lane highway, that's a completely new type of facility. And so the historic crashes are not going to be a good indicator of the type of crashes you're going to have in this new 4-lane highway, because they were related to the 2-lane road. However, you could use EB to prove that the need for upgrading that 2-lane rural highway. So it could still be part of your project, but it would not be part of your comparison of the alternatives. So it could be part of your evaluation of historic.
Right.
Yeah.
So then the first and second and third would all be applicable. But I'm not sure about the freeway, right? Because I'm not sure how I would model that.
Yeah. Good point. Yeah, maybe not the third one. And I guess it's pretty important for us to be clear and point out. So unless you're using it for PSI and historical analysis, you absolutely should not use it for 1, 2, or 4 for a future comparison to modify predictive, because the crashes on the road for the last 5 years are not going to be a good indication of future crashes once you've made these fairly substantial improvements. That just, I'm going to say what it makes me think of all the statements that you hear. If you're, future, what is it? Past performance is not an indicator of future performance, and companies will say that in their things. And it's true with crashes, that if you make a big change, then it's not going to be a good indicator. If you're not making a big change, it actually, in this case, is a good indicator. Sorry, I had to have a few things to say. Since most of the slides here until the break are all yours, so
No, good additions. I was just going to ask Adam, if there are any questions?
So there was just 2 quick questions, I guess, about this example, but one question was just about converting from the second thing, converting always stop to signalized. I think Rob, you mentioned it, but the crash types and things like that would differ. I don't know if you want to expand on that anymore, but just the trends would change. And then the second question was, doesn't widening the shoulder change the typical section?
It does, but it's not like changing. If we were just, I mean, I don't know how often one would just add 2 feet of shoulder width from 6 to 8, but let's say that's happening. We wouldn't expect a substantively different safety performance in terms of the types of crashes that would occur. So I would argue that the historic crashes would likely be comparable to the future condition.
And the adjustment factor that you would use for the 2 feet would account for the change. So you would actually, one of the factors in the equation would change, but you could still use the historical data to kind of move it up or move it down, is basically what you're doing based on how people are driving that road. Other factors that we haven't accounted for. So you still would get the change though with the adjustment factor.
Yeah, okay, so I think that's kind of the key. You guys have said it already, but just to reiterate, like it is primarily when things are not changing, but it's in the theme of how crashes are likely and safety performance is likely happening in that area or at that intersection. So if we think that it's a little subjective because of that, but if you think that it's not going to change, you could potentially use EB.
Right, exactly.
Right. Yep.
And since I asked Adam if there were any questions, I am reminded that Adam asked me to say at the beginning, what I didn't say is that we wanted to let folks know that the slides will be available. And also we're gonna go through the questions after the session. And if we're going to respond to all the questions, and we're going to get those out too. So if we don't get to your question, we might in the follow-up. So let's see, we have those 4-ish steps, right? We have find our SPF, find our adjustment factors, apply the calibration factor, and if EB is applicable, go ahead and use it. All of that relies on developing like these homogeneous units of analysis. And in the HSM world, everyone calls it segmentation. So there's this process you do of taking a look at your facility and dividing it into uniform analysis units, uniform segments. And at the broadest level, you have intersection and segment crashes. So that's like the first big separation you make. And then for segment crashes, then there's, for each safety performance function, there are different cross-sectional features that influence this segmentation. So number of lanes, shoulder type and width, median type and width, access density, all these things influence what your homogeneous unit of analysis is. And again, different facility types have these different features. So for example, on an undivided multi-lane highway, these are the characteristics that influence segmentation. And in urban and suburban arterial, these are the factors that influence selection of the SPF. So this segmentation step really is a very, very fundamental and critical piece of estimating your outcomes, because every unit or all of the analysis builds on identifying facility types and then selecting safety performance function, adjustment factors, et cetera, et cetera. So that segmentation piece is super important. And different softwares, if you use the Integrated Highway Safety Design Model, IHSDM, it's great. It does segmentation for you. It becomes more of a black box, but it's a great sort of analysis or data management tool. If you use the spreadsheets, you have to do the segmentation yourself. So it's an important step. So at the end of the day, what do you get? You get some predictions. And so it can be presented in a table or a graph, but fundamentally, as we see on the left, for your analysis years, maybe there's a current year and 20-year future year. You can predict fatal and injury crashes, PDO, and total crashes, and you have that for your no build and your build condition. And then you can do the comparisons and compare and contrast results. So this is predicted crashes. So at best, you've applied the safety performance function, the adjustment factors, and the calibration factor. If there's not a calibration factor, then you've just applied the SPFs and adjustment factors. And then I might argue that you should just report the change in crash frequency as a percentage rather than a number, but something to think about. Now we've mocked up you know, an analysis to show that crashes go down with our build condition, and we do see that, but we also see that crashes go up with your build condition, and that can happen because often with your build condition, traffic goes up. And traffic volume is the most has the greatest influence on the crash prediction. So when crashes do go up with your prediction, you got to start looking at rates and seeing what that does to your results. Maybe crashes go up and there is a mitigation that we should think about from a safety perspective. So the results aren't always as clean as this. So how do we get through all of this? A lot of steps, and I am going to try and use. I'm not going to do it. So fundamentally, you've got to figure out your data needs. You do this segmentation, which, as I said, is the most critical step, because this is identifying which equations you're going to apply to which pieces of your network. And then you would apply the safety performance functions, apply the adjustment factors, apply the calibration factor, and predict crashes. Now, as I mentioned, depending on the software that you're using, at a minimum, applying these factors and getting predicted crashes, and even the EB, if it's appropriate, these are done in the software. So you don't have to, you're not going to the manual and looking up these equations. If you use IHSDM, that model will do the segmentation for you. But as I said, it gets kind of black boxy. So then you would do this for every year of your analysis. And this is something to keep in mind when we do a traffic operations analysis. You know, you'll do your build year, your opening year, and 20 years forward, and then compare and contrast. Well, when you do safety analysis, you do opening year and then each year up to your design year, or your 20 years forward, because crashes unfortunately are occurring every year. And that's an important thing to remember, particularly if you're going to do a benefit cost analysis. So once you've repeated steps per year, and again, the software is set up to do that for you, you get your outcome of predicted or expected crashes per year, and then your totals. And depending on the models you're applying, you get that by you can get that by severity level as well. And if you're doing arterials, you can get pedestrian and bicycle crashes. So that's kind of the method in a nutshell. Now that's, you know, that's a skimming across the top to give you the concept. If you diving into the depth could be a whole nother course in and of itself. And while it's, you know, while it's a valuable tool to help us, there are, of course, limitations that we need to be aware of, right? And so you got to account for calibration because of variability in driver population and weather. Something that is super important is we're doing 24-hour predictions, right? And particularly in urban areas, that's not accounting for variations in daily flow and peak periods and the differences in traffic operations and probably crashes as a function of the peak periods. The freeway model accounts for this with a factor, but so that's not accounted for. And then there are a lot of facility types, or I see that we didn't finish a sentence here, or innovative intersection types that aren't accounted for. You know, DEIs, there are some CMFs now, but they're not in the predictive method. Right now, the freeway method is limited to 5 lanes in each direction. That is maybe only marginally useful in Florida. I've done projects in California where it's almost never useful. And right now, HOV and HOT lanes aren't included, though there's some research that should be coming out this year about that. So it helps, it's the best available, and with all things, it's not going to be always our solution, and we're going to have to sort of cobble things together, as we talked about a little bit yesterday. So that's the predictive method in a nutshell. Now, we do have a break scheduled. I don't know if we want to just keep going, Rob, or
we can keep going.
Yeah, let's keep going.
We can keep going.
In that case, you're up.
Yeah, I'll have to give me a second to get my presentation up, but it won't take long.
All right, you should be able to share.
While I'm thank you. While I'm doing that, I'm going to just say that you mentioned the percent versus absolute, and that's a pretty important thing to think through and make sure that can be used to overcome some of what you were just talking about. If you have a situation where the predictions, you know they're in the right direction, but you just don't know the magnitude, you don't have confidence that the magnitude of the crash predictions you're coming up with are what they need to, are accurate for your facility. That's where sometimes you go with just percentages. So based on the information, we have a level of confidence that we're going to decrease crashes, or that this would increase crashes by X to Y percent, this range of percentage increase or decrease. And that can help you work through some of the limitations. So Beth, I'm gonna make sure you see my screen. All right.
Yep. Before you get started, I'm sort of scanning questions too. And somebody asked a couple things that we can address real quickly. Maybe you did already, sure. Adam, I don't know. When is the second edition of the manual coming out? It's a year or two away. We don't know for sure yet. HDR is on the team to develop the second edition, and at a minimum it's a year away, but depending on the additional work, it could be 2 years away. And then somebody asked if EB is the same as PSI, and Adam, again, if you address this, I apologize for being redundant, but it is not. You use EB in order to be able to apply the PSI. And so the PSI is the difference between the expected prediction and the predicted prediction. And so that's that. Just wanted to clarify that.
Yeah, we said, I did reply to that one.
Oh, good. Okay.
I said almost the same thing as you. The other thing I pointed out was the time difference. The PSI is for something that would have already happened. You're evaluating historically past events, whereas EB, you're typically looking, and the predictive, you're typically looking to the future.
Yeah.
You don't have to, but yeah.
Right.
All right.
Okay, sorry about that.
No, it's good. We're good, and we will get into. For everyone, we're going to get into more complexities as we go through the rest of this predictive kind of session and discussion. There are things to think about, and then ways to kind of work around things to get to good and reasonable answers. But it does surface sometimes some important safety issues when it surfaces important safety issues we need to be thinking about. So I'm going to go through an example, widening a 2-lane highway to a divided 4-lane highway. I'm going to let you know that some of the material that we are going to be presenting today, just like yesterday, comes out of the guidebook. So I just wanted to kind of flash a picture of the guidebook up here that is available to all of you, available online right now. You can, if you don't have it, you can go get it, download it. And it has good information there. And then Beth referred to the calibration factors. Those are in the 2015 manual, HSM user guide. So, and those are available to all of you. I just wanted you to know that. So we're pulling from documents that are there for all of us to use. So this example, we got a 2-lane highway that is proposed to be widened to a divided 4-lane highway. A lot of traffic demands, and so maybe traffic is the first the reason that this project has surfaced, and you've got this PD&E study to look at this. And so the first thing that you want to do is kind of size up how are we going to tackle this project. And so there's a scoping, which we're going to talk in the next module about kind of scoping from a slightly different perspective, but here we want to scope out what we're going to do for the predictive method. And we want to define that study area, and we want to, and I am going to, at risk of causing trouble here, we want to define the study area, and I got to change color.
Bold, Rob.
Yeah, I know. I need bold. I don't know how to get it to be wider.
No,
so
you're bold. You're bold to try it.
Yeah, I'm bold. Yeah. So actually, I use the highlighter. So yeah. So this is, you know, you work through the study area, and then your analysis years. And Beth just talked about this, that with the spreadsheets, you get 1 year of analysis. And so you can do, here we are doing 2022 and 2042, and that lines up with what the traffic operations team on this project is doing. They're going to do, you know, an opening year and a future design year, and so we want to align. But often for what we report, we want all the intervening years, and especially if we do a benefit cost, then both the safety folks and the traffic operations folks have to provide all the intervening year data as well. And you can use linear interpolation. I would just say that that is not, with safety, that isn't necessarily an exact number. If you linearly interpolate the crashes, because the safety performance functions are curves. And so things do not, it's not a straight line between the two endpoints, but that is an approximation that could be used. When you use the tools, like Beth mentioned, IHSDM, when you use some tools, it will do all of the calculations, and so it will linearly interpolate the volumes, or you can put in volumes, and then you get a kind of a more exact set of numbers. So just, you want to define that at the outset. What are our years? Are we doing intervening years or not? And that is, again, a change from what the traffic operations folks are often doing when they might be looking at endpoints. And so you need that to think about the middle potentially. And it also makes it easier to report results, so that especially for the high severity crashes, you've got numbers that folks can kind of understand, and you're not dealing constantly in decimals of crashes. So again, looking at a longer time period kind of helps get things into whole numbers. So that's analysis years. Roadway type. In this case, we've got a rural 2-lane, rural 4-lane divided. There's codes that apply, and then that defines the safety performance function. And then here, what are the tools we're gonna use? And so we've shared some. We're gonna actually share some others later today. This is the spreadsheets, the FDOT modified HSM spreadsheets, and then we've got our segment length, our forecasted traffic information, and then our calibration factors. And you'll notice Beth talked about often the build, it will involve a higher traffic volume. And so that's the case here. We're predicting that on opening day it'll be the same, but by the end of the time horizon, the volume will be different, and sometimes they're much different. And that, and we'll actually do something with that later on in the session today. So
Rob, I'm going to interrupt you
please,
before you change slides. So this table, I think, could be a really useful table in a scoping memo, right? Where at the end of the day, this kind of summarizes some of the major assumptions that you would be doing in your analysis. And you could also, for example, yesterday we talked about where, you know, if our, let's say our traffic volume exceeds the limits of a model, you could have that caveat expressed around this table or in this table, and, you know, from a documentation perspective up front, we could all go, okay, these are the numbers we all agreed to. And because again, this really drives your results, what equations we're using, and as Rob will demonstrate in a moment, the calibration factors that we're using, these really influence our results. So just wanted to point that out.
Yeah, no, excellent. And again, this is in the manual. If you're like, you know, if you want to look at examples, it's in the manual. And, all right, so data. There is quite a bit of data that goes into these models. We are not going to go over all of this data. And when we do the examples later today, we've already put it into the models, so you won't have to enter in all of this data. But there is a good bit of information, and it matches, like Beth said, for each model. There's specific pieces of information that are required. So for these, for this base model, this 2-lane model, we need to know the lane width and the shoulder width. and we need to know about horizontal curvature and important characteristics that will allow us to get a good prediction for the no build condition, roadway. So you enter all of this information in, and it will it's necessary to get the prediction. Then for the build, the build model requires fewer inputs in this particular case, but it has, again, lane width, shoulder type, the side slopes again, and so the various factors that are required for this type of highway are entered into the model. And so at that point, you've kind of laid out your assumptions, your process, how you're going to do this. You've got your data, and the data goes into the model. And so this is basically the screenshots of the model that show that where the data goes into the model. And again, we're not going to go through each one of these in a lot of detail, but I just want to show you, goes in, and you can see that just the things that change. Once you've got something set up, it can be pretty easy to replicate it. This is now the row multi-lane sheet with the data, and then I'll point out it's got that calibration factor. The other one had a calibration factor of 1. This has a calibration factor of 0.68. And so that means that your prediction is going to be reduced to 68% of what it otherwise would have been. All right, and then these are the CMFs that will in the future be adjustment factors. They will be AFs in the future, but right now they're still shown as CMFs. And this, even if you're not doing this, so someone else did all that other work, they got all the data, they put it into the model, and you should check and ask the question, what are the major CMFs? And if you know something should be influencing the crashes, you want to highlight that. And so right here, you can see that the shoulder width here on the left and the driveway density, they're moving the needle, and they're causing us to have a higher number of crashes than other two-lane rural roads. And you want to make sure that this rings true, that this is in fact what you expected. That's on segment 1, and we divided the segment based on shoulder width, and you can see that plays out. The shoulder width for the second segment, where it went from 4 to 8, the 8-foot has the wider, the wider shoulder has a lower CMF, and so, but it's got a curve, and the curve shows up in that. So you want to kind of understand enough, or at least make sure that someone on your team is understanding that this is doing what we expected it to do, and that we're getting the right answers out, and don't let it just be that black box. So that's, you don't have to look at all of them, but you do want to know, here it really is driveway density on the first one and the shoulder, and then the second one, it's that curve. Did we get the curve in there right? It's a 14% change in crashes. And so that is, to me, a pretty important thing to do. So the second one, the CMFs are pretty modest. We don't have a lot of changes, or AFs I should call them. So we're gonna be pretty close to the base. What's gonna change the number here is what I showed you before, that calibration factor. Okay, so I guess what I'm trying to say is, as you go through this, make sure you know what the needle movers are. What is changing from the base, so that you've got it. You make sure you've got it. It's telling the right story here. So we get to this. This is the calibration, that 0.68 that I mentioned, and that's an important factor here. Okay. And so I'm following through the steps that Beth just showed you with the boxes generally, but now we've gone through, we've entered the data, we've done our prediction, we've checked our calibration factors, and now we've done the calibration piece, and now we're to the end. And so before I go into the end, I will just say, Beth, anything to add, or Adam, any questions thus far that we want to, before I dive into the numbers here? I'm not going to dive in, but before I start talking about the results.
Well, from my perspective, if you go back a slide or a couple of slides to looking at the CMFs, like these, this one in particular, when you're working in the spreadsheets, these are kind of in the middle, so it would be easy to look past them and just go to your results. Right. But you know, like anything when we're doing our analysis, right? We want to understand what Rob said is like what's moving the needle and does it make sense? And in particular, if you know we get a situation where the crashes increase, we want to be able to look at these CMFs and go, well, what's driving things the most, and is there a situation where I can do some mitigation? Or you know, if I can't mitigate those highlighted in peach or salmon or whatever color that is, maybe there's something I can do elsewhere that will offset those increases. So just giving that another shout out.
Yeah, so I mean the data goes in at the top, and this is and then you got the CMFs all right here, and so they're not, you just don't want to, they're all embedded, they're all done for you, all the calculations, if they're equations or lookup tables, it's all done for you, but you can kind of go here and look and see, and these are the ones you see right there, the 0.93, 1.14. So you just want to kind of go and find those and make sure that that's from the example yesterday. This is again from the book. So okay, yeah, good point, Beth. Go ahead and go to the results. So the results, again, we got 2 analysis years, and we've broken out our crashes by segment 1, segment 2, and then the total for no build to kind of know how the segment, how the crashes are playing out in each segment, and then we've got the build, and then we've got a crash reduction. We're showing a pretty good reduction here, and that is, but we broke it out by severity. You can see that the reduction is larger for the property damage only crashes, and that is something that you want to pay attention to is the change by severity, as there are cases you'll see later today when one might go up and one might go down, and you've changed something where those safety performance functions for very specific, a lot of them are developed separately for severe crashes, the fatal and injury crashes for compared to the property damage only crashes. And so that separation is pretty important and is valuable and useful to us as we do our work to make sure that we aren't mistakenly reducing total crashes, but increasing severe crashes. And so you want to pay attention to that as you go through and look at your results and start to kind of sift through, like Beth said, if you need to do any follow-up or propose anything back to the project team. So that is really the end of that kind of quick example. We're going to do another example together.
Rob, I had a quick question. Yeah. I think other people might ask if you go back to this slide. So 2 questions, I guess. One being the accuracy or quality of the results. So what is, like you're showing a lot of % change here. What is is there a threshold or an accuracy level of number of crashes or anything like that?
Well, I'd start with, I'm showing here 1 decimal place, and Beth and I were talking about this a couple days back of that there are a couple of schools of thought. One would be to keep everything to whole numbers of crashes. When you're looking at a single year in a short segment, that the rounding errors start to be an issue and the ability to understand what's going on. So that can be problematic. You can solve that by showing a decimal, which also shows that it's in fact a calculation. It's not as, it's a calculated number. So you can use that 1 decimal to show that. You can also change it to show to show additional years. And if you show a 20-year time period, all of these would move into the clearly into the whole number category. You can start to work with numbers that folks are more comfortable with. And it depends on your audience. So for this presentation, this audience, I'm showing you these to 1 decimal. If this was a public presentation on this project, I might decide to show the 20 years and not show any decimals so that the public isn't kind of confused by that. How can I have a half of a crash? So, so your audience is important as you're thinking through some of that. So that's part of the answer. Beth, did you have more to add?
Yeah, no, I mean, I think what you just said, particularly the audience, is really important. And I think definitely when you talk about these numbers, talk about the results, it's, you know, I wind up talking about whole numbers and saying, oh, it's around 2, you know, that difference, or converting it to some average per year that people can relate to. Yeah.
So Adam, the other part of the question, at least what I heard you say, is these are, you know, maybe the word approximately needs to be put in. And these are, we're not certain of these numbers are based on distributions and so so that's where, yeah, you could round those percentages as well and report, for example, we think crashes will go down by, you know, a rounded percentage. You know, maybe it's 25 to 30% for fatal injury and 65 to 70. You know, or you can put some rounding and some ranges on these numbers to show that we have but they're good numbers. They're based on the best information we have, but they are not that exact.
Right. So, and from a sort of a detailed technical perspective, there's sort of regularly there's discussion among the researchers in the Highway Safety Manual and at TRB about providing these standard error to these equations, just like there are with the CMFs, so that we can talk about that range.
Right. So that is, yeah, those are excellent questions, things to consider, think about as you're deciding, again, based on your audience, whether or not, you know, what kind of information you show, and putting brackets on. I would say these numbers are substantial enough that I think we can say this, you know, in this scenario, we expect to reduce crashes. If it's, you know, we predict the crashes will go down. Maybe the magnitude is not exactly what we're showing here, but it's not an increase. It appears to be a decrease. So you got, you know, at some level you can start to draw conclusions, especially when the numbers are like this. So, all right, I'm gonna go on to the next slide. Unless, Adam, was there one other, or was that it? You said.
There was a question before. There are some others, but about blending methods. We talked about this yesterday a little bit, so just correct me if I'm wrong, I guess, here. But if you had a different CMF that didn't interact with the ones that are being applied in these equations, I could then, at this stage, once I have all the totals, apply a CMF, an additional CMF, for example. Yeah. So if you needed to blend two analysis types because the CMFs aren't in these spreadsheets, you could do that here, but there is a caution due to the fact that some of these equations might have some bleed through affecting the CMF.
Right. So. Yeah, so I just flipped to, actually I'm gonna flip to the four lane multi-lane highway, and yeah, if there's something that's not accounted for here with shoulder type and median width, and you know there's some kind of treatment, and you know that we're going to apply that isn't addressed here, that's completely independent, then yeah, you could apply it at this point. And it's kind of like the DDI example that we did yesterday. I mean, the DDI, it's a CMF after you've done your prediction. All right, good questions. All right, the predictive method tools and resources. So I mentioned now yesterday and again today the FDOT HSM spreadsheets. There are also on the other side here the national 1738 spreadsheets. Those have been updated a little bit, and they've been cleaned up a little bit. They look better, and they're easier to work with now. they didn't change any of the underlying equations. There was one little mathematical cleanup in one of the sheets that was affecting decimals of crashes. They fixed, I believe, but generally those should be the same. There's kind of different spreadsheets that do the same thing. Then in Florida, we also have SPICE, and then we have the Florida specific calibration factors that we've talked about. So we've got a variety of Florida specific tools and things to think about. And then the national side, ISID, IHSDM are for freeways. Well, ISID is for freeways, ramps, and ramp terminals. IHSDM is for all types of roadways for which we currently have safety performance functions. And so I'll say Beth mentioned one way, and then there's 6-lane arterials have been added to the kind of repertoire of safety performance functions, and they are only in IHSDM. And so if you want to do calculations for those types of facilities, I think roundabouts also, so I think they are only in IHSDM. And so you can't use, there's no spreadsheets for it, at least I don't have any, and there's no, I think you have to use that tool. So that is just something to keep in mind. Again, as you're picking tools and you're scoping out your project, if you know you have a one-way road that you're gonna need to evaluate, you're gonna have to use IHSDM to evaluate at least that piece of road. You can mix and match, but because the equations are the same, just some tools can do certain things and some can't. So so definitely things to think about as you're entering into a project and scoping it out and making sure that you're not going to get caught later on having to switch things up. That they don't talk. You can't copy from one to the other. So Beth, I think that's it from me right now. I pass it back to you.
All right.
If there are questions about any of those tools or you want more discussion about that, just let me know. We can bring that up later if you've got any specific questions.
So we got a few little summary slides and some Mentimeter, and then we'll take a quick break. So documentation, again, it's an important piece of what we do in PD&E and in the safety world. So, the safety work should be included in the project traffic report. I am seeing this evolve from a section of the study to an actual chapter. So that's good to see. And these are the kinds of things that we document, right? The study area, the period, the alternatives, the data, the methods, the tools. So essentially, kind of if you think back to that table Rob showed at the beginning, we're looking to transparently document what we've done. So if it had to be repeated, it could be, or somebody can use their judgment and go, yeah, I agree. And then the results, when you get to that point, the evaluation, it should show how the safety goals are being addressed, or the safety purpose and need, perhaps we should have said, is being addressed, or how what we're doing is not having substantive negative impacts. And then you want to be able to compare and contrast results across alternatives. So similar to any other work we're doing, it's document and then evaluate. And then this is sort of a repeat of what we've been trying to present, right? For there's the existing analysis and then the future analysis, and that existing helps us define should safety be a specific need in the purpose and need, and should we be proactively thinking about it, yes or no? And no is okay, no is good, right? And if yes, then we better speak to that in our documentation. And then the future analysis are the evaluation of our alternatives, which is so hard for me to say. We've got various tools. We can use crash modification factors with a relative comparison, where you're just applying CMFs, or we can apply CMFs to observed crashes. As we were just talking about, you could also apply CMFs to a prediction. And then we can use the predictive method. So safety performance function, just use the SPF. If we have a calibration factor, apply that. And if we can, go all the way and use EB in order to estimate, sort of re-estimate observed conditions. So a lot of tools are available, and the guidebook sort of provides an overview to these options, and then there's of course lots of other resources about how to actually learn and do. So we've got a Mentimeter. Let's see if I can. Okay, so we'd like you to select the 4 main elements of the predictive method. And so down here we've got CRFs, adjustment factors, AFs, SPFs, safety performance functions, calibration factors, DDIs, EB, the PSI. I'm not as tough as Rob. I go ahead and show it right away. All right, we'll see if we can get a couple more responses.
Yeah, thanks to everybody who's participating in this part of it. It's just good to.
So yeah,
While you're out there.
Fundamentally, it's the adjustment factors, the safety performance functions, calibration factors, and at times the EB, the empirical Bayes method. And then, you know, obviously there's that segmentation step that's a critical piece of this. The next question is, does FDOT have SPF calibration factors? It's a little bit hypnotic to watch these change. So I'm gonna let it hit 70, and then all right. The short answer is yes, they do. It's on the FDOT HSM webpage, if I'm not mistaken. Rob, I think you showed it earlier.
Yeah, it's in the 2015 FDOT Highway Safety Manual User Guide has them in there. But yeah, you can go to the webpage there. And we're going to talk more about them later because they, there's discussion, just ongoing discussion about them and the use of them. But yeah, that's where they are.
Is the EB method applicable to the PD&E process? Yes, always. No, never. Maybe if they're small facility changes. So this has that same complexity that we didn't think about when we were writing the question, Rob.
So I just answered. This is the first question. I hadn't answered any questions, but I figured I'd answer.
So when we wrote the question, we were thinking maybe if there are small facility changes, but there's also the you can use the EB to apply the PSI method to determine if safety should be a primary purpose and need. So maybe that falls into still maybe, or maybe that falls into yes always. I'm not sure, but that's the complexity we didn't anticipate when we wrote the question.
So it will be for a lot of projects. It won't apply to the alternatives analysis.
Right.
It'll be a limited number for alternatives analysis, but it'll be valuable for your historic work.
Yeah. Thank you for clarifying.
No, I'm just repeating, not clarifying.
Okay, and that is it for Mentimeter right now. So I think that takes us to a break, which means I need to get my slide back up.
And I will say before we go on break, when we come back, we're going to start with case study number 4, and then we're going to roll right into case study number 5. So hopefully you all have, there are 3 files for each of those case studies. So hopefully you have those 6 files. If you do not have those 6 files, please go into the chat questions and type, give Adam your email and he can send them to you. Hopefully you all received them. Most of you seem to have them yesterday, but those will be pretty important for the next part of the class. So. Welcome back, everybody. Hopefully, a good little break here. We're going to dive in on this case study number 4, like I said before, and I'm going to ask that Adam and Beth, as we're going through this, this case study is a little bit more involved, and please chime in as we go. I just have one little technical question. Adam, can you see, or Beth, can you see me? Because my camera thing isn't working on the side. Can you see me okay?
Oh, no. Yeah, we can see you fine.
Yes.
All right, so I can't see myself, but I don't need to. Okay, so excellent. So case study number 4, arterial example. We've got an urban condition where we've got a couple miles of road, a little over 3 miles of road that currently has a center 2-way left turn lane, and we got a PD&E project. We're looking at converting it to a raised median, at least that's the concept on the table. And so there are a variety of reasons, we're kind of pursuing this project, and we've been asked as a team to evaluate to predict safety performance if we make this change. So this kind of gives you the layout. There are 2 separate segments and there are 2 intersections involved in the project. Go to the next sheet. It's got that same general table that we showed you before that lays out the scope and method. So again, this is a good way, like Beth said, to kind of clearly outline how you're going to tackle the project. So here we've got the study area is a little over 3 miles in length, and so we've got this study area here, 3 miles, and then analysis years 2020 and 2040. We're going to use the urban 5-lane with 2-way left turn lane, the 5T for doing the no build, and urban 4-lane 4D for the build. And then we've also got 2 intersections. So unlike prior one, now we've got to call out the intersections. One's a 3-legged intersection, one's 4-legged. They're both signalized. And so the build, no build SPFs are actually the same. And the assumption here is that we're not, there's turn lane. The turn lanes that are there are there in the build and in the no build, so no difference. So we kind of work through and pick the SPFs, the tools, got segment length again, and then our forecasted volumes down here. And so in this particular case, at this point, we are assuming the volumes to be the same. So that lays out the the situation. And now let's go ahead and dive into initial steps. The no build alternative. We're going to open the files in just a minute here and review the no build file. And then we're going to actually transfer some summary results into a summary worksheet that you were provided with. And for the build, we're going to do the same thing, look at the file, transfer a few key pieces of information into the summary worksheet. And I'm going to pull them up, and so I'll do it on my screen. Encourage you to kind of work along with me to understand the sheet and what we're doing, because there's going to be a next step to this, so it'd be good if you just kind of do it on your own and while I do it on the screen. But so go ahead and open up the 3 case study files. The names are here on the screen: No Build 2025, HSM Build 2025, and the Crash Summary Worksheet, all for CS4. So the No Build, let me get the right file here. All right, so the no build sheet looks like this, and got the introduction tab on the far left, and then segment 1. We've entered. I've kind of the red box is not normally there. I drew that so just to draw your attention to the fact that we've entered the data. The data has been input into this sheet already for segment number 1. Got the volume, got number of driveways, all the information has been entered. And again, this relates to an example in the workbook if you want to look back at it. Then segment 2, same thing, enter the information, and we're going to be able to get a crash prediction. And again, for reference, the CMFs are are down below, and you can investigate those and see kind of how they factor in. So yeah, so for example, lighting, we've got lighting, and so we have the CMF 0.94 for lighting. All right, then intersection number 1, just kind of working across here, we've got the data entered there, and we've got the AADT for the main street, the side street. We've put in the calibration factor, so I'm going to zoom in so you can kind of see that a little bit better. Gone ahead and put in the main street traffic, side street traffic, the calibration factor, so it's all in there. And importantly, down here you'll see there's left turn phasing information. And so for signals, there are a number of kind of specific items that are important to predicting crashes at signalized intersections, including turn phasing, the presence and absence of turn lanes, presence or absence of protected permitted phasing. All right, and then intersection number 2, same thing, we've entered that information. So this all ties back to things Beth has been saying about the AADT, and make sure that you need, again, for the sometimes we need a little bit different information than maybe the operations folks need. We want those daily volumes at these intersections. Okay, so now we go to the urban site total. So it is tab number 8, from left, and it's the urban site total tab, and it provides a summary of the crashes by type of crash and segment, and type of crash and intersection. It also provides a summary of the bicycle and pedestrian crashes. And so this is one place you can go. Some of this information is also available at the bottom of the sheets we just looked at. It's also available on another tab, which is the project total. But right now, let's just focus on this urban site total sheet, which I've got the boxes kind of drawing attention to the key output information. And this little table off on the right is not in the spreadsheet. If you go and download it from a website, I've added that so that I've done a quick summary of the key pieces of information for the fatal and injury and property damage only crashes for intersections and segments. So this is a quick summary of the no build predicted crashes that uses all the things Beth talked about, the safety performance function, the adjustment factors, calibration factors. At the end of the day, these are the numbers that we get. And so what we're going to do is take those 4 numbers and we're going to put them into this summary, crash summary worksheet. So we get the crash summary worksheet, and I've got there's a place, the yellow highlighted cells, be a place to put the no build crashes on the left here. And so go ahead and do that. I'm going to just pull it off my screen to do a quick copy. And I am doing it right along with you. And so we get a number of crashes for our no build, and then we also calculate rates at the bottom part of this table. So we've got numbers of crashes. It does the totals by severity and totals by facility type, and then the total for all crashes. And then down below, we've provided the information necessary to get exposure so that we can calculate rates. And we talked yesterday about how to calculate rates. And so that information is here and gives us a starting point. These are our no build crashes and our no build crash rates. All right, so I will just pause, say, Adam, any questions before I move on to the build?
Nope.
Okay, just making sure. So let's go ahead and pull the build file over, and we're going to do the same thing and go through it a little bit more quickly, because the information is pretty similar. We've entered it, but you see here that in row 9, if I zoom in, we've got the 4D. We've switched from the 5T to the 4D, 4-lane divided. And so we've done that in both tabs. And then we've got our intersections, and they are unchanged. And then we go to the urban site total. We've got the same information there. So you can kind of look around, see that the information has been changed for the build condition. And really that's the biggest change, is to pick a different SPF in this particular case. All right, and then we're going to go ahead and copy the 4 summary numbers again into our workbook. So we'll go ahead and paste those in. I'm going to say one other thing here. So so I've pasted them in, but before I kind of go there, I do want to just draw your attention. We are using columns D, E, and F, which are the predicted numbers. We did not put the observed crashes in column G in either of these spreadsheets, as we're not using empirical Bayes. So we are not getting an expected average crash frequency. We are working with predicted numbers, and that wording you hear us using is very specific to the HSM. So it's predicted is what we're using, because we can't do expected without using the empirical Bayes, and we are changing the road, and we think enough in this case that we wouldn't use empirical Bayes. So we've made that kind of project team decision, that we think the crash types are going to change once we get this raised median in place. So could discuss it, debate it, but that's the assumption made here, and so we're not using EB, and but we are still going to get a very comparable set of numbers for these 2 scenarios. We've got good predictions, got good information, and everything's in the ranges. So this is kind of a good use of all of the tools that we have available to us. So we put those numbers in.
And we have calibration factors.
And we have calibration factors, right? Exactly. Yeah. So we put the numbers in, and we have a reduction in crashes. Our reduction is we've got almost a crash a year. Again, I left these as one decimal here.
Could you zoom in a little bit?
Absolutely.
On the sheet, and maybe if you could just really quickly highlight again where you grab these numbers on the worksheets. Someone just was asking to go a little slower, and I think maybe that's the question.
Yeah. Absolutely. That's why I was asking before, because I knew I went a little quicker the second time around. So it's the urban site total tab is where you can get the summary numbers. And I've embedded this little table in here that does the summary for you. Normally you would have to go do this yourself. and you'd have to pull the numbers out and say, I want. And so I'll just explain that a little bit more. That column D is total predicted crashes.
Maybe even make this a little bit bigger too.
Yeah. Column D is total predicted crashes. Column E is fatal and injury predicted crashes, and column F is PDO crashes.
And then it's separated top half by roadway segments, and then the bottom half for intersections.
Yep. So the top part is segments, and we've got multi-vehicle non-driveway, single vehicle, multi-vehicle, driveway related crashes. So there's three kind of sets of calculations that the spreadsheet is doing for each roadway segment.
So this is a question yesterday and today, but if you have this project fits in the default spreadsheet setup, but if I had a project with 5 segments, I would just need to copy the tabs and then reference them in. The first 2 are referenced. Like Rob, if you could click in D14, you'll see it'll show that it's probably a reference to another cell in the workbook. So if you add other segments, you copy the tabs, and then you'd need to reference them in here manually.
So one of the changes that was made in the AASHTO spreadsheets is that they now have, I think it's 8 or 10, I think it's 10 segments and intersections.
Oh, okay.
And it's all set up to automatically reference. There's some macros and stuff that automatically reference, makes it a little bit easier to do exactly what you're just saying. So, yep. So you want to, go ahead.
Oh, I was just gonna add, that's a reason, if you're using the AASHTO HSM spreadsheets, and for that matter, Florida's, it's probably best to sort of always download them as a starting point, rather than to pull something from your files, because chances are there could be some updates that would be beneficial.
Yeah. Yeah, if I can, maybe later I'll show the AASHTO one and just show it's got a little bit more functionality. That's one of the things that they did, was added more functionality from this is the initial work built by Karen Dixon, and yeah, so they've been kind of trying to keep upgrading. So we've got the information here on the segments and intersections. Again, it is important to know that the pedestrian information is kept separate. Those are calculated in a slightly different way. And so the numbers end up being pulled out, and you need to make sure that whatever you're looking at, you've got them all added together. So if you use this particular tab to do your work, you'll need to add them back in, and they are all assumed to be fatal and injury. There are no PDO ped bike crashes. That's just the way that is the way it is calculated right now. So, all right. So with that information, I'll go back here. So we've calculated out of that site totals tab the 2 sets of numbers. And then this is just an example. You can summarize this data in a lot of different ways. There's a lot of other information. This is for some projects, this would be more complicated than you need, and for some, this would be too simple. But this is a way for us to at least get our arms around it for this specific project. So we want crashes, we want crash rates, we kind of want to know what's happening at the intersections versus the segments, and severity. So it gives us, for this type of project, I think enough information to start to see where this analysis is leading us. When you get into more complex projects, sometimes you might need to have more segmentation. You might even break out, for example, did not break out single vehicle versus multi-vehicle, and that just different projects, you need to think about it in different ways and do different things. And sometimes there's post-processing. Here we don't have any post-processing we need to do to those numbers for CMS or anything. So so we get it in here though. We get these sets of numbers. and this is not an this could be a real project. It's not unreasonable for it to be this level of complexity, but not more. Sometimes it's less. Again, sometimes it's more. Sometimes this is about right. So here we go ahead and we calculate the change in crashes for fatal and injury. That's really one of the first things for me that I would look at is what's happening with my fatal and injury crashes. I'm interested in the bottom line number. I made that bold the bottom line, I guess, but honestly, that's really where I look to see if the direction this project is headed for safety is fatal and injury. And so I'll look there. Here it's good, 7% reduction. Property damage, 5% reduction. So we're doing better with fatal and injury than overall 6% reduction, about a little over 2 crashes a year. And then down here, our intersection rates stay exactly the same. We did not change anything on those intersection tabs. So the intersection crashes are actually identical. But so the segment crashes is where all the change is, and that's what we would expect. And we've got a reduction in crash rates of 10% for fatal and injury and 8% overall. So it looks good. I mean, this is a benefit. Now, I say it looks good, but this is an expensive project. We're gonna, potentially we need, and it's gonna have some. The public will be very interested in this project, right? We're changing access, so this gives you the tools to begin to look at if you need to benefit cost and what are the benefits of this for safety. So that gets us to the first step. Adam, if there are no questions, I want to move on back to the presentation for the next step.
If we have time, there are a few questions. I'll try to summarize down to 2 or 3 here. Is that okay?
Yeah, absolutely.
Okay. So one question was about, I think this is a good question just in general. If we're doing this type of analysis, then do we need to do a historical crash analysis for a project?
Okay. So the short answer I would say is yes. Yes, you need to do that historical to demonstrate that there's a need for the whether or not let me rephrase that, whether or not there is a need for safety to be part of your purpose and need, and if it is, then you know that you need to try to address it with your project. So if you did the safety analysis and it showed a significant safety issue and you run these numbers, you're showing a benefit, but then you could ask yourself, well, is this enough of a benefit? And if you ran these numbers and it showed a decrease and safety was part of your purpose and need because you'd identified an issue, well, then we need to change our build alternatives to address that purpose and need. So to me, the historical analysis is really essential every time. The level, you can adjust how much you're doing. It might be not as in depth because you might be able to very quickly identify that it is not an issue or that it is an issue, so that you might not have to go. The depth of that analysis can vary, but I think it needs to be part of every project for PD&E.
Yeah, I completely agree. And the depth of the analysis, you may not slice and dice by all the different factors for all the different scenarios, throughout the study area, but it's understanding, again, should safety be in the purpose and need? And if not, are there any trends that we need to address in our project nonetheless?
Right. Okay, Adam, others?
Yeah, there's another question here, which I think other people might have a similar question, but the different driveway types. So on the input spreadsheet, it's asking about commercial driveways, residential driveways, etc.
Right.
So how do they impact the number of crashes? And how important is it to get those correct? I guess I'm adding on to the question, but.
Yeah, I would say that it is important to consider that and to get in there. I mean, I guess, you know, I'm hesitant to say it is important to pay attention to it. You know, if we look down here, you can sometimes do a sensitivity analysis and see if it's going to move the needle. I mean, if, you know, the difference between 20 and 25 may not be significant for, you know, for example, minor residential driveways. That's just not going to change things really substantially. And so if you are, again, thinking about the scaling your efforts, you might just make an assumption there. Again, document it. You know, this is my documented assumption. This is what I assumed, and kind of keep moving. But we typically do fill those, and we fill those all in. We will make sometimes we'll make estimates. You know, you see these are all rounded to the nearest 5. That's not uncommon. You know, we'll get numbers to the nearest. You know, we're kind of, this is the order of magnitude, and should work for this analysis.
Yeah, I agree with Rob. And taking a look at how sensitive, you know, what's the range of the CMF as a function of my numbers will also tell you, right, how refined I need to be.
Right. Just looking to see, yeah. Yeah, we maybe come back to that. Go ahead, Adam. Next one. Just gonna try to do a sensitivity. What's next question?
Oh, sorry, I was trying to reply to some as well. I think this would be a question that you answer later, but what if some crashes go up and some crashes go down of different severities?
Okay, yeah, so with that question, let's press on to the next one, and if we can circle back on. I can maybe even demonstrate the sensitivity analysis, but let's see. I go ahead and pull back up the presentation here. So actually, yeah, I've got a couple of manometers. So we've already talked some about this, but I'm going to go ahead and put these up on the screen here real quick. What are the initial results? What are the initial results indicate? And this is kind of open response. So just you know, if you, again, put yourself in the shoes. This is your project, you know, and I just handed that analysis to you. You know, what do you draw from that? And from some, yeah, from different answers, you might think, you know, maybe we need to do something more. Maybe this isn't enough for this project. And I do look at it and I wonder, is that going to justify, you know, if safety is the reason we're doing this? Am I convinced or not convinced at this point? All right, so let's see. Yeah. Good. Small safety benefit, safety improvement, decrease. Benefit, I saw one about the fatal injury there. Yeah. Need to do a BC, potentially good project. That's definitely where my mind was going.
Minimal benefit.
Yeah. And so I'll say often, you know, we find ourselves, you know, we don't want to overestimate those benefits. So to me, I, you know, want to be careful about that. And you know, I'm thinking a raised median should have a good benefit, but so variety of factors at play. So
I like 20 less people will be severely injured or killed. Do the project. Boom.
There you go. Yeah, so that's where
I like that.
that's, so when you do the benefit cost, that can bring that really home too. But yeah, that's I'm actually going to pull up the summary again. Right, so this is 1 year, and so if our fatal and injury is going down by a crash, almost a crash a year,
Yeah.
and that's that's on a 3-mile piece of road. So 3-mile piece of road. So yeah, that's where you got to kind of pour over it, dig into it, think about it, and while you're looking at those first 2 boxes up there, that's very helpful. All right, good answers. Thank you all. I'm gonna have one more question on this. Inputs and factors influencing the results. Did you see anything that jumped out at you? As you're looking at the spreadsheets, maybe you're looking in there and I don't know, maybe the person who was asking the question for saw what the CMFs were. Are there CMFs that are driving this? Anything that you think the project team should know about? I'm going to say just one thing, that lighting has a is a factor in this, and not everywhere, but there are many highways where we have good lighting in Florida, and I think that so I know again it's not everywhere. I'm just saying, but there are compared to other states, we have good lighting. So yeah, all right. So yeah, all good answers. I'm not gonna. I'll leave this up just for another little bit here, but yeah, the calibration factors, right? So actually, as you're typing things in, I'll scroll through it. Yeah, that 1.63 calibration factor. So I just to show when we say that has a big impact, I'm just gonna flip it off, just so you could do this on your own. If I was to flip that off, which makes it uncalibrated. So I'm not saying you do this. This is not, but just so you know that it makes a difference. The numbers are going to be very different. And so 4.5, 11.5. I didn't affect the intersection, just the segment. And so if I put those in there, need to apologize, you folks are typing. I'm going to flip it back in just a second, but so now we've got a 33% reduction. So that's why I say, pay attention to what's moving the needle, know what's influencing things, and then be able to report that back to folks, or ask the questions. If you're that project manager, you're responsible, you're the reviewer, ask the questions like this one. What's driving this? So let me scroll through these a little bit. So yeah, lighting, speed, geometrics, accurate. You want to make sure that ADT, the length in the ADT exposure, that drives everything in these equations. And if someone has an inaccurate length, you can't compare it, and things will be off, and you're trying to dig through it, and you're trying to look for lighting, and it's the length. You got to make the ADT and the AADT and the length are key things that have to be examined. You need to make sure that your build and no build, that everything is comparable, and that you know what you're comparing. So I can't emphasize that enough. Okay, so good answers. Thank you. Let's go on to the other part of this case study. So we're going to, I'm just going to tell you, so this is what happened. You were working, you did this, and then the forecasting, the traffic forecasting folks came to you and they said, hey, you know what? We finished up those forecasts you asked for, and the AADT in the build is actually going to be 30,000. So we think the traffic's going to go up. So again, suspension, what is it? Just imagine, right? So I don't know why in this particular case, but just play along that the AEDT goes up to 30,000, and so we're going to need to change just a couple of inputs to test out what that means. So, and they say, all right, and the team wants to know, well, what does that mean? And everybody's in a hurry, and so you pull out your spreadsheet again, and
that never happens.
Yeah, no, never. And make sure I set this back. I gotta undo, and get that back to where it was. Get the calibration factor back in there. And so you go into row 11 on the segment 1 of the build tab. So again, the forecasting team gave you this new AADT for the build scenario only. They're saying if you build this raised median, there'll be more traffic. Okay. I'll tell you what that does. So we put in the 30,000 in the row. It's row 11, and we're going to do that for both segments. 30,000 for both segments. All right, so get that build file open and make that. It's one change on each sheet. Everything else is exactly as it was before. No other changes. Just the new forecast came in. And then we're going to make one change on each of the intersection sheets, and it's the same thing. Let's row 10 now, where we update the AADT for the intersections. So essentially, we're going to change those 4 numbers. And with that, we've done all the changes we need to make. We just need to go to the urban site total tab and pull out our new numbers. So we'll go back just to make sure if you if you just got it open or something, it's row 11 in the segment tabs that you're going to change to 30,000, both of them. And it's row 10. Zoom in here so you can see it better. Row 10 in the intersection tabs, where that's the major street daily traffic. So 30,000 for row 10. So you change those 4 numbers, and then go to your urban site total, get a new set of numbers, and copy those into. I don't have to. Yeah, I think I got it fixed. Okay. Copy those into the right-hand side of the crash summary worksheet. So now we've got data in all of the yellow tabs. All right, so I am gonna pause there and let folks kind of catch up if they are. Yeah, so it's just like it says on the sheet there. 30,000, changing all 4 input tabs, enter the results in the summary sheet on the right side of the sheet, which is over here. And lo and behold, our crashes go up. Not unexpected, our volume went up. So now, since our volume went up, our crashes are going to go up. And so suddenly the bottom part of this table gets even more important than it was before. Before it was important, you wanted to know what was happening with your crash rates, which is basically the effectiveness of the facility, the performance of the facility on a per exposure basis, per vehicle mile traveled or per entering vehicle. So to me, that is always a very important measure. They're both important. The one is important for the magnitude, and the other is important for kind of the rate. Are we making the rate better or not? And in this case, the total is going up, and we can explain that to the project team. Well, now traffic's going up. We're serving more people. There's more exposure. Our crashes are going to go up. And then you've got a good story on the segments, but our segment crash rate is still going down. We're those on a per mile traveled basis, we're we've got good performance. It's better than it is now. So we're serving them better on the segments, but at the intersections, it's worse. Our rate is worse, and we've got more crashes. And so the project team just continue on and says, we don't like that outcome. We do not want to show that. We don't want to make the intersections worse. We need to do something. What can we do? What can we do to make the intersections better? And so I will ask you that question. What can you do to make the intersections better? And let me just go ahead and so I will ask that. So actually I'm going to go ahead and do the next two Mentimeters. So how did the results change, and then how could the build alternative be modified to reduction in intersection crashes? So let's go ahead and pull those over and give me your thoughts on that. What do you think the new results? Again, so you got the data in front of you on your own screen. How do you interpret those results? And if you don't have it in front of you on your screen, I can you can cheat and look at mine. I'll make it smaller. So I see more crashes, improve, crashes go up, increase. So you can take a snapshot of my screen if you need to now, and then I'm going to move it off so I can see what people are doing. Increases, more crashes, higher volume, higher likelihood of crashes, right? Okay. All right, so I'm going to flip to
the more challenging one.
Well, actually, I need to scroll down. So for segments, worse intersections, right? Focus area that increase. Increased crashes, exactly. Remove some of the movements such as yield, free forward returns. Safer segment. All right. All right. So good stuff. Let's go on to the next question. How could the build alternative be modified to a reduction in intersection crashes, to yield a reduction in intersection crashes? So what can we do? What can we do to the project team is not happy with this result, and or your project manager, nobody's happy. What can we do? What can we do to improve this? And you can, this is an opportunity for you to work on your own to test it. I've got an idea that I will show you here in a minute, but you've got the spreadsheets and can kind of test it out on your own. Add lighting, projected right turn lanes, evaluate alternative intersections, roundabout, CFI, modify the signal, roundabout, do a nice analysis, good. Add turn lanes with better signal coordination, lower speeds. Potential for alternative control measures at intersections, change geometry, turn lane, signal timing, protected phases, get additional turn lanes, CapEx.
Do nothing. You could decide.
You could decide this is
okay. That's part of the game.
Right. All right. So I got a number of good options here, and actually I'm going to protected turns or turn lanes, protected turning movements. I'm going to pull around the revised build model, and say so my just kind of for purposes of this, I thought, well, I've got protected permitted, and maybe this permissive is yielding to PEDs. That's the third leg. But on the main street, if I can go to protected only phasing, and I would just change that. I'm going to zoom in on the two intersection sheets. Right, I only care about the intersections, and I want to test out protected phasing, and I want to go to the traffic ops part of my team and say, hey, can I do protected phasing? Can you put that in, run that, see if that works? If we have the capacity for protected only, that could help. And so I put protected only in rows 21 and 22 of the 4-legged intersection, and only in rows 21 of the 3-legged intersection, the 3SG. So I changed three locations from protected permissive to protected only. I go back to my urban site total. I grab the numbers out of here, and I'm going to drop them in here. And now I'm still showing an increase in crashes. I have more traffic. It's not going to be easy to come up with a reduction in crashes when I'm serving an extra 6,000 vehicles a day. But now all of my rates, I have mitigated the rate situation with the intersections by switching to protected phasing. And so the model would predict that we've got a decrease. It's not a big decrease, kind of just keeping the status quo for the rates. But again, I told you it's nonlinear, and we've got this situation where by just adding traffic, we're changing the rate slightly, and now I've mitigated that. And so now I've got a situation where I can go back to the team and say we are serving the public better in terms of looking at exposure. I mean, every mile driven through this corridor is a safer mile driven than when we started, but we have more crashes because there's more people driving it. So to me, that is how you can use this tool as you're working through your project, and you see what does it tell you, and then what happens when you change things. And then really here we've got two alternatives now, and folks can kind of pick which one. We'd have to change the 30,000 for the first one, but you can then compare and contrast and look at, as the one person said, how many crashes are we preventing, and you could do a what if, where what if that much traffic was going through? If you want to show people, well, if we were really apples to apples and we had 30,000 for the no build, this is what the numbers would be as a point of comparison. It's not a real scenario because they can't get through, but this is what would happen. And we are definitely better than that. Is the kind of thing that you got to, when you're talking to folks about these analyses. And so I will say it is tough. What we've got on the screen right here is very difficult. You got a project and crashes are going up, and everyone's, well, I don't want the crashes to go up. Well, we're serving more traffic. And so that's one of the things that you have to wrestle with on a lot of projects. And so there's a variety of ways to address it. I kind of spell out part of one, but going back and doing the apples to apples, well, the what if could also be part of that. I mean, there's a number of other things you can do too. And so it's just, again, got to be thoughtful. Make sure that you're conveying accurate information in a way everyone can understand. So, all right, Beth, what else have I missed, or Adam, are there questions?
I think that's great. I'll just add maybe a story from experience to the point about crashes going up as traffic volume goes up. For a project that will remain nameless, in a state that will remain nameless, we were working on a big interchange improvement project, and a project like that, right, it's been going on for years, and for years safety had been in the purpose and need statement. But it was more like a throwback thing where, years ago, you would always say safety is part of my purpose and need, because anything we did was improving safety. But by the time we got to the NEPA analysis, the demonstrated safety need, there really wasn't a safety issue on the corridor. By the time we got there, it's a target zero environment now. These are just PDO crashes. It's not high on the state's ranking list. And then we do whatever improvements we're doing, and crashes go up. And so there was it was a very sort of dicey situation to navigate because safety had been expressed as a primary need, when in fact it was a congested location. We were talking about low severity crashes anyway, and relative to other places in the state, it wasn't very high. And then to boot, we had that increase because crashes were going up. So it's just proceed with thought and caution as you would any other aspect of the work we do.
Right. All right. Cool.
Rob, I do have two questions about segmentation. Just what are the overview of rules and when you need to create segments? Should segments be every change in the cross section, or is there like a guide to what's acceptable and how short or how long could segments be?
Beth, you want this one or you want me to? I feel like we should.
Well,
good either way.
Tag team it. That that's gets to the art form of doing this, and so I think, if I remember right, I think there's a statement in the manual about the segments don't go shorter than 0.01 miles, but I don't remember if that's you're nodding, Rob, so I think you remember that number.
Yeah.
As well, or we both made up the same thing. But so there's that, and then the way I think about it is you don't want to get so short that you can't particularly on a freeway, for example, or a higher speed facility, if vehicles are going by some change in the cross section in no time, how might that affect your safety or not? So I think about that a lot. So it's really like substantive things that could influence how crashes occur. And there is some guidance in the manual about things like shoulder width, if it's, oh good, you're pulling it up.
Yeah.
Sort of the rounding that you do. So it's an art form. I don't know, Rob, how does that?
Yeah, no, I agree with you. And so it's the homogeneous with respect to characteristics for traffic volumes, roadway design characteristics, and traffic control features. And so you're trying to get these homogeneous sections. But you don't want to get so caught up with every little change. I mean, these tools are based on the equations we've been showing, and it's kind of and all the spreadsheet tools, even IHSDM is kind of a souped up spreadsheet where each piece is looking at the inputs that you give it, and it's not like a simulation model or anything. It's each piece looks at the inputs that you provide and does these calculations, and there is guidance in here for using weighted averages. If your shoulder kind of goes in and out, it's 8 and it's 7. You don't need to just break it into an infinite number of little pieces. You can break it into a lot of pieces, and because of the nature, that spreadsheet nature, it'll calculate all the little pieces, and IHSDM will do that for you if you use that software. But if you're doing it yourself, I guess we've always used kind of a common sense, look, yeah, nothing too short. I mean, if I start getting down to 50-foot segments, I'll do that sometimes if there's a 50-foot design exception or something, but a lot of times it's, we want to kind of have things in little meaningful chunks that we can kind of understand, and that we think are representative of that facility, how it's functioning, and not kind of overcook it, so to speak. There's guidance in here.
I would also add, I completely agree with Rob, and I would add, think about, he hit on this, but think about how you're using the outcomes of your work. You know,
Right.
if it's a design exception, you might need to be more specific, and it's usually a smaller section anyway. But if it's a large scale, more of a planning level assessment of maybe traffic operations strategies and trying to understand the implications of those, then maybe just more bigger chunks can be okay. Bigger, longer segments, skipping some of the details can be okay. And I think of it in the same way. I've done a lot of traffic operations analysis in my past as well. And so, you know, there's sort of the critical movement analysis that you can do to get that first cut assessment, to a detailed microsimulation model you might need to do at a congested location and you're needing to establish signal phasing. So it depends on how you're going to be using the work as well, that depth of segmentation.
Yeah. So sometimes there are times when making some simplifying assumptions that don't, your overall length stays the same, but your gore points are 50 feet apart and on opposite sides of the freeway, and you say, well, I'm going to align them. I'm not going to have it. They're a hundredth of a mile apart. We're going to call that the same. And so, there's things like that where we'll make those, again, try to keep it reasonable and rational. All right, Adam, other questions? Is there anything else? I've got some questions up here for case study 4, just things to think about. How did calibration, we actually looked at that. Calibration had a pretty big impact. Was an important thing to think about and make sure you've got it in there. And then what factors are not in the spreadsheet that you think should be considered. I'm sure some of the things that were mentioned, were not in there. I mean, so speed, for example, is not in the spreadsheet. Why do you agree or disagree with the results, and how would the results change if the build used roundabouts? So you could actually now test that with the new SPF. So there's a lot of things to think about, and then how get into when you discuss a project like that and you're presenting it to others, or asking questions about it of folks who've done the work. So, all right, Adam, we're good to go?
Yeah, there are some other questions, but I'm thinking maybe we'll address them as we go and we'll follow up at the end.
Okay. All right, sounds good. All right, well, it's time for the second case study, or the last, for today, and second and last. So we're gonna do case study number 5. It's a freeway example, and CD roads. And again, we've entered the information, so you won't have to enter a bunch of information. But this does, will show some of the complexity of doing freeway projects and the challenges and things. So hopefully this is useful to you all. We've got a project shown area. The top is the current condition. Figure numbering is, again, because this is coming out of the manual, so you can refer to that if you would like. But we've got 2 diamonds that are closely spaced. And the proposal on the table is to run CD roads along the freeway and kind of connect them. And again, not saying this is a good, is just for example purposes, right? So play along. It's CD road, and folks are asking, all right, so how is this going to impact safety? And we're doing our operational analysis over here, and we'll get you those ADTs you keep telling us you need. How's this going to impact safety? And you see we've segmented it here, segment 1, 2, 3, 4, and 5. In the top, we've kind of aligned the gores, so we end up with those 5 segments, and then 3 segments on the bottom. And then the ramps are going to be part of the analysis. So that's the kind of setup for the project and the analysis, the study area. And And so as we've been talking about, study limits and segmentation are very important. You know, one of the things that every project, you have to make sure, again, no matter where you are in the process, but especially if you are a reviewer comment, did you use the same study limits? And so is your exposure the same? And I just want to keep emphasizing that, because that can lead to the wrong conclusion if someone kind of runs to that, well, this project stopped here and the other one went further. No, they've got to always be the same. And for every alternative, no build and all builds, we got to have the same exposure, or it's not comparable, and we won't be able to do, we won't work out, right? So, so here, the site limits, segmentation, make sure that that's all defined, and that you are able to then kind of track it through. Make sure that you're gonna get to answers that you can use and even relate back to segments. So sometimes at the end of a project, you might want to map the predicted crashes back to your figures, and you want to kind of be able to track all that. So, all right, so that's the setup. And during scoping, we decide that it's going to be Interstate 100 and mile plus 0 to 2.1. And we're going to look at 2 years again, because we want to match the traffic operations, although you may decide, and you'll see here in a minute, that leads to kind of an interesting outcome when you do the 20 years, we want the 20 years. So actually, we're gonna actually talk about all the years when we do this, but we kind of have set endpoints, and then got freeway with 2 diamonds, CD for the build, freeway with 2-lane, CD, and then we've got a number of lanes and SPFs. So just kind of working my way down the list here. The tool we're going to use is ISAT-E, and the segment length is 2.1. And we got our growth rate and calibration factors. We don't have calibration factors for freeways in Florida, so it's none. And we're not going to use EV. So that is the scope and methods for this particular example. And we're going to use ISAT-E. And so we're going to review the no build alternatives, review the file, enter the results, look at the build, review that file, and enter the results by facility type and severity into the summary worksheet. So that's the next thing to do. If you haven't already opened up those files, I would say go ahead and open up these 3 files, the no build, all the CS5 alternatives, no build, build, and crash summary worksheet. So similar to last time, 3 sheets. There are embedded macros, and so you need to enable the macros when you open those up. So the no build file looks like this, and it'll open up with at least mine, yellow bar. You want to enable the content so that you're able to run it should you need to run it, and build, and then there should be a crash summary that looks like that. All right, so those are the 3 spreadsheets. I'm going to go through the first one here. So this is the no build spreadsheet. Just need to all right. Okay, so let's go ahead and walk through this. It opens to the main tab, far left, where you enter some information here. And if you've never used ISAT-E, I will just tell you that the year's really important. And then this no crash data, if you're not using EB, you definitely want to check that to no crash data. Lots of people run into all kinds of problems. And so tip for someone who maybe had trouble with that is off on the right, there's a clear temp button over here. And sometimes you have to clear out the temporary data to get it to let you put in the years. So for those who are never going to use these spreadsheets, you can just move past all that. But the years, sometimes you have to work through the years. There are the spreadsheets sometimes a little finicky. So the first tab after the main is the input freeway segments, and we've gone ahead and entered all the data in for the freeway segments for the no build condition. So number of through lanes, the length, the lane width, and all the information here. So that, and if you scroll down, see there's information about the ramps. So I'll just scroll through these so you see what's in there. So it's number of I'll also zoom in a little bit. So number of through lanes and segment length is in there. Very, very important. And then whether or not there's any curvature, then lane width, shoulder width, inside and outside, median width, presence of rumble strips, shoulder, and various things. So in a another project, there might be more information here where we've got more information about the median and the shoulder width. Clear zone information for roadside data, and then all the ramp access information. How far away are ramps? Are they at drop or speed change lanes? That's the SC is speed change. Are they right side, left side? And then is there a type B weave, which we'll talk about in just a minute in the section. And so in this case, we've got a type B weave coded in here. And then we've got the information for the other direction. So one of the things, if you're unfamiliar with the way the freeway analysis works for the Highway Safety Manual, both directions are examined at the same time. So unlike the operational analysis, where on a freeway it's one direction only, for safety, it's both directions are evaluated together. And that leads to often more segmentation. If ramps come in at different places, you need to segment it for both sides at the same time. You got to work through that segmentation process. So very important to realize that, and so when results are coming out there for the entire facility, and so just good to understand that for freeways, it's both sides for the main line. And then proportion of traffic during high volume hours and the freeway volume data. That proportion of traffic during high volume hours, something you can go in and calculate and change. It doesn't always lead to as much of a CMF factor as I would sometimes like it to, but it is what it is, and it's there, and it's one of the few things that you can use to address highly congested areas. So there's so that is in there and available. And then in here we've got all the volume data put in, as well as all the ramp data. And so this is important. The top and the bottom are very important, the length and this volume information. Okay, so if you've got questions about that, please go ahead and type them into Adam. Either Adam can reply or I can go back over something. But I'm gonna move on to the ramp segments. So that's the next tab. And we've got data entered for all 8 of the ramps in this no build condition. And so it's number of lanes, then the segment length, and then the average traffic speed on the freeway, and then the segment type and type of control at the crossroad terminal. And then we've got information about the, there's no, we assume straight ramps, no horizontal, although that can go in there. And then the cross-section data. So it's lane width, shoulder width, presence or absence, presence of lane add or lane drop by taper. There's, a lot of information that really has an impact on safety goes into these spreadsheets. And then roadside data for all of your ramps, ramp access data, if there's ramps connecting to ramps, and then your traffic volume data. And I'll just mention, yeah, that's the end for ramps. There's less information required for ramps, but the information about barrier, and barrier, sometimes folks will kind of be tempted to skip over barrier, but barrier has an impact on crashes, and it has an impact on severity. And so I'd encourage you, we had that talk before about driveway density. Barrier is something you want to pay attention to. You want to make sure that it's comparable between alternatives when it should be, and that it's not, and that if something is actually going to change, that you capture that change if you can. I know often we're doing this pretty early in the process and all the barriers necessarily set, but it is something to think through. Barrier influences the equations, and it's not something to be skipped over too lightly. If you know, again, you might decide, well, we're going to make them the same, so it's comparable, but be thoughtful about it. Even though that does take a little bit of time to think that through and solve that. So, Beth, any thoughts? That's the end of the input data for this example.
No, I think you walked through it. I think you walked through it well, and you know, your message a few minutes ago about the segmentation and it's a bi-directional prediction of performance is a good one to remember, since again, it's not typical from a traffic operations perspective. And so as your freeway situations become more complex, the fact that it's bi-directional makes this even harder to deal with.
Yep. Okay. All right. So where we've entered the input data, and we're going to go to our output summary. And so the output summary provides the crash prediction, and it's not highlighted if you download this from the web, which this is free on the web. It isn't highlighted like this, but I've highlighted the crashes for freeways and for ramps, and both the total and then by severity. And so those are the numbers that you can look at, and then you've got the annual numbers, and there's all kinds of additional information. There are estimates, I think I mentioned this yesterday, by type of crash, and sometimes this is a little, to me, I wouldn't lean on this too heavily, but you certainly can look and see if it tells and gives you useful information. But we're starting to kind of parse things out, split things into smaller numbers. And this is based on averages. You might want to do this based on localized data rather than what the defaults are in here. But it at least gives you something to look at for single versus multi-vehicle and types of crash by severity. So it's a starting point and can be useful. But back up to the summary totals, that's where we want to be right now, and want to pull over the crash summary workbook. I've got a place for you to put the 10 numbers right here. You do need to transpose them, so they're rows, and you're going to need to make them into columns, and so you can enter them however is your preference. I'm going to do a copy paste here, and so I'm going to highlight those, do a copy, go to the other cell, do a paste, special, and values, and transpose, and okay, special puts them right in there. Values, transpose, puts them right in there. So follow that, you kind of pull those numbers out. I just, to me, the value of getting in there and looking at this, you'll see we're going to make one small change here in a minute. And again, if you're not a doer, but just knowing what is kind of enough about what's happening behind the scenes that you can ask the probing questions to me is pretty important. And so we've copied in our crashes, and just like the other sheet, we've got a number of crashes and a crash rate. For freeways and for ramps, we've calculated them separately. So just like intersections and segments, we separated freeways and ramps. And then we've got the totals by severity, by facility, and then the total, and which matches the total over here, 1349.4. So that's kind of our starting point. That's our no build. And we did all 8 ramps. We did the 5 different segments. So now we're going to pull over the build file, and we're going to do something similar. And I'm not going to walk through that in as much detail, but just to show you there's only 3 segments for the build, and that same information has been entered. So we've entered all the information, and we've got that type B weave that was in there is gone now. And then for the ramp segments, well, you're gonna have to bear with me a moment. I'll keep playing through. I gotta reopen my Excel. It crashed. So apologize. So the build, yeah, we'll get right back in there. The build has the ramps. Yeah, let's close that. And apologize. All right, so it should look like this. Sorry, the freeway has the 3 freeways, and then the ramp has, it's going to be a problem. I'm going to describe it to you. That the ramp has 4 ramps in it, and all that data has been entered as well. And I don't know why Excel is going to do this to me, but that's all right. It keeps it exciting. So on the tab here, we've got the number of crashes that the build is predicted to have, and you can see that they are different. And so we'll go ahead and put those into the crash summary worksheet. I'll say if you have questions about the build, and if for some reason I'm not able to make it work, Adam, you can share your screen and we'll walk through it. So I'm going to go ahead and put those in here using the same process of gotta paste special and values transpose, and I'll get my other ones in there. I'm going to go ahead and close this out so it doesn't give me problems. All right, and so with the build in there, if you've been able to copy that in, and I will have it in just a moment, you can see that, well, I guess, what do you see? I'm gonna, all right, so it should look like this. All right, so we've got our no build, we've got our build with the CD road, we've dropped everything in, we've got number of crashes, and we've got changes in crash rates. And so I'm going to give everybody just a minute to either screen capture this if you didn't do this, or follow along, do it yourself in the sheets. And I'm going to pull back up the presentation. I've got a couple of questions I want to ask you about this before talking any more about it. Other than to say, you might notice at the top got a strange number in row 2, crash summary, 21 years. That's because we picked we picked the operational analysis years, which I think of fences, and you got the posts, and then between the posts, and we've got 21 posts. We got 21 years because of, in this case, I set up the spreadsheet 2025 to 2045. And if you count, if it's inclusive, you end up with 21 years. Often that's why for safety, we'll say, we'll have a little discussion with the operations folks and say, well, 20, they want those 2 years, and so maybe we'll do those and match them. And then maybe for the 20-year analysis, we'll say, well, can we do the first entire year that it's open to traffic? And so we'll slide that back to 2026 and 2045. And then we got a 20-year period, or just use 21. I mean, there's more than one way to do it, but just wanting to be aware, that's why that number is strange. Adam, we've never had that conversation before. It's all right, so let me go on to the next question. What do the initial results of case study 5 indicate, and what are some important inputs and factors influencing the results? So a pullover Mentimeter, those are the questions. Just be thinking about those things. What do the initial results of case study 5 indicate? What do you see in the spreadsheet? What do the initial results of case study 5 indicate? And I'm going to pull this back around. You've got your Mentimeter on another screen or on your phone. So if you don't have it, you can look up my screen and make it a little bit bigger. How would you interpret these results? And Beth, I'm not looking, it's hiding my Mentimeter, so I can pull it over. What do you see?
Yeah, I don't have my Mentimeter up. I'll pull it up and let you know.
Oh, I grabbed it.
So seeing things like trade-off freeway, but the ramps, freeways improve, but the ramps not so much. Crashes and crash rates tell a different story. Safety improvement along the freeway. Increase in crash rates of low severity crash types on ramps. Decrease on the freeway. Crashes go down as a system. Another way to look at some of the same findings is better freeway operations at the expense of more PDO ramp crashes. So that the getting to the trade-offs that we have to consider. So that's it.
All right. So one of the things that jumped out at me when we put this together was, so many of you mentioned there's actually two things. Is the shift in crashes. Freeways are going down, ramps are going up. Ramps have typically a slightly higher crash rate, and so we're shifting more traffic from the lower crash rate facility to a higher crash rate facility, and so that's being reflected here. But that is a real issue in a lot of projects. So we have an operational solution that maybe leads to longer and more ramps and moves traffic off the main line that has generally a lower crash rate onto these other facilities, and we're braiding things, and they have higher crash rates. That go back to that, they have barrier maybe on both sides, and maybe the shoulders are narrow, and so that all plays into this. And so this is not an uncommon result to have your freeway crashes go down, your ramp crashes go up, your total crashes go down, just by virtue of kind of how everything is playing out. So sometimes it goes up. I will say that the KA numbers, they go down, and they go down for both freeways and ramps as a rate, and then and then the total goes down just a little bit. So anyway, there's a lot to chew on here and to think through and kind of look through. But I'm going to go ahead and jump to the next question. Inputs and factors influencing the results. I'll just see if you look at those spreadsheets, what might be leading us to these results. And then we're gonna have a news flash. Someone's gonna stick their head in your office and tell you something. What are things that are influencing these results?
May have to provide your feedback, Rob, about what you see as influencing things.
Well, we'll give people a few more. I see a few more things popping up here.
Okay.
We got volumes, weave, merge, diverge, change, less traffic on the freeway.
Oh, there we go.
And more ramp traffic due to CD Road. Yep. Yeah. And we'll pull over spreadsheet. And I guess show where the CMFs for these ISAT-E spreadsheets are on these three output sheets off to the right of the output summary. And so you can go in here and look at these CMFs and see which ones are really moving the needle up or down, or you can ask someone else to do that for you and tell you what is moving the needle up or down. And I'll just draw your attention to this one. Segment 3 has a CMF of over 2. So that particular segment, which is the middle segment, the weave segment, has a CMF of over 2. And so that is an attention getter. And it's in the lane change CMF, which is where you handle lane changing dynamics and the length, distance from a ramp, an on-ramp that is upstream, or an off-ramp that is downstream. And it also handles the, I mentioned the type B weave that's in there. And so that's one thing that is really moving the needle. There's a few other things. I mentioned that high volume CMF, it's 1.111. And then the ramp exit, we got, where the ramp exits are right there. We've got CMFs that move the needle there. And then it repeats them. I mentioned before that this is for property damage only crashes. So this top part is all for your fatal and injury crashes. So these are pretty important CMFs up here at the top. I didn't mean to scroll down so far. That move the needle for your fatal and injury crashes. So that's one place to go look. And so look at this. Wow, 2 is a big number. And so actually the news flash is that so you're sitting in your office, you're poring over these results, thinking about it, and the person that did this work for you and sent you this summary said, "I'm sorry, I made a little mistake. I didn't fully understand the weave piece, and I actually didn't mean I shouldn't have coded the type B weave. I didn't I wasn't sure what A, B, and C types were, and so I said yes. And so just a quick refresher that type B weave is shown on the left. This is right out of the Highway Safety Manual. It matches other documents, and including the HCM and Highway Capacity Manual and others. But so we got a type B weaves are on the left, where either someone getting on or someone getting off does not have to make a lane change. They can just go straight on, or they can go off without changing lanes. Typical type A weave is shown on the right, and it's traffic gets on, we've got an auxiliary lane, traffic gets back off. So the person mistakenly coded a type B weave on the right here and they're like, yeah, I did that wrong. Should have been a type A weave on the left. And they say, just let me go run back to my office and fix that, and I'll give you a quick update. And so we're gonna do that. We're gonna run back to the office and fix this seemingly small little, make this small little tweak, type B back to a type A. And so we go into the no build sheet, and we're gonna just toggle 4 items again. There's just 4 things that need to be changed to go back from a type B to an A. So in the freeway segments tab, where if you go to the freeway segments tab of your no build sheet and you go to column K, there are 2 places down in pretty far down in the ramp access data. It's row 76 and again in row 90, where it says, yes, I have a type B weave in my segment. And if you don't have a type, if it's type A or type C, there are type Cs, you want to say no, I don't have one of those I don't have one of those kinds of ramps. And then I want to do it here. And I'm a little concerned my macros are not going to work, but it's all right. Adam, I might need you to give me the numbers. And so you're going to click no there, and then go to the one other minor change that the person doing it needs to make is to go to the ramp segments and turn those back into 1. So they're all 1s. So they mistakenly coded a 2-lane ramp and a type B weave. They shouldn't have done it. So, but that's it. Those are the 4 things we need to change. We just need to change on the freeway segments in column K, those 2 type B weaves to no, and hopefully yours goes white underneath there. Mine did not. And then in the ramp segments, just make them all 1s. So every ramp is a 1-lane ramp. And this is a change of the no build, just to kind of get it to the way it should have been. So this is a more typical situation where the type A weave comes on, auxiliary lane comes off, typical weave. And then you go to the main tab and you hit perform calculations. And hopefully it's going to work. So those are the 4 changes. Change the type B weave on the freeway segments, change the number of lanes on the ramps, go to the main tab, hit perform calculations, go back to your output summary, and we've got another set of 10 numbers here.
He says with relief.
Yeah, right. It worked. And so you're going to take those 10 numbers and put them into your no build. And that will be, this is the last thing I'm asking you to do. This is it. So we're no more, so we're gonna paste values, transpose, drop them in there. And so this is a typical type A weave compared to this CD road concept. So, and person ran to your office, they apologized profusely, but it didn't go anywhere. He only just sent it to you. He just finished. And he caught it and fixed it, and so here we are. So then he sends you this new spreadsheet. It looks like what you see on my screen. Hopefully you're able to either follow along doing it yourself, or you just look at my screen, and it looks like this. Suddenly, the freeway is still going down. We're taking traffic off the freeway, so it's going down. The ramps are going up, and now we've got an increase in our fatal and injury crashes overall. We've got a decrease in total crashes. This is where it gets complicated. I got a decrease in total crashes, but we don't have a decrease for our higher severity crashes. And that's pretty important to us. And interestingly, the rates are actually going down, but because we've shifted the exposure from the freeway to ramps, which have higher rates, we've gone up a little bit. So there's this, the equations aren't, again, they're not linear. There are different equations for high severity and property damage only crashes. And so we've got this kind of mixed bag of results. And often it's like this, where you get it and then you have to figure out, well, what do we do with this? Do we, just like the one where we changed the protected permissive to protected only, maybe we need to do something else here to try to address this issue. And so the prediction is raising some issues. You're solving an operational issue potentially, but maybe you're creating a safety issue that you need to look at a little more carefully and spend some time working through. Is there something we've missed, or do we need to do something different? And so to me, this is often kind of the real world complexity of dealing with freeways, weaves, ramps, and there's even more that we could talk about, but I think that gets at those issues. So I guess I'm going to pause, or even stop. I'm gonna go back to the presentation. Hopefully you've been able to follow along generally. See if, yeah, I had two quick questions. So I've talked about this. I will go through these. How do the results change? And why is there an increase in certain types of crashes in the corridor? And so I'll go through those here quick, give everybody a quick minute to answer, and then, yeah. So Beth, I'm watching the clock here, and I want to get this back over to you. Yeah. So
maybe we get through these real quick, take a short break, and then take it home.
Yeah. In fact, I'm gonna just I'm gonna kind of scroll through this. I think we've already talked through these. And I do want to, we do want to keep things moving. And I think that was a lot of detail. Hopefully you were able to follow along. And Adam, you probably have some questions. I am inclined to just kind of go on to the last piece of this, just questions to think about. How did calibration factors affect the results? In this case, they didn't. They were not part of it. We don't have them for freeways. And other factors things should be considered that were not considered. And why do you agree or disagree with the results? And how could the build project be modified to reduce the high severity crashes? So those are important things to think through with every project. So with that, I'm actually, that's the end. And I can leave these, the Mentimeter going, but
I think we'll take maybe a 5 minute break, and and then come back and do the key takeaways from this module, and then do our next module.
All right, and then that last one is the scoping.
Yep.
All right, so
we'll reconvene at 4
o'clock. Yes, 4 o'clock. It's 3:55. So 5 minute break, reconvene, and then just to wrap up. And the scoping we will still end I think a little bit early.
Yes. All right. Talk to y'all in a minute.
All right.
Well, we will get going again. Starting with our sort of takeaways from talking about the predictive method. So first and foremost, there are the 4 kind of buckets of analysis, right? The SPFs, crash modification factors, which will be called, as we've mentioned, adjustment factors. Adding your calibration factor when available, and then the EB when appropriate, which we have hopefully conveyed for the alternatives investigation. It may not be appropriate very often for the purposes of identifying whether or not a site or a project should be a primary need in the purpose of need. Then EB may be appropriate pretty often. Lots of resources. So there's FDOT HSM spreadsheets, the SPICE tool. There are calibration factors available from the website. And then there's different models, IHSDM, the ISAT-E tool that you were just working in, and then the HSM spreadsheets. And it looks like our links aren't necessarily working, but as we mentioned, especially if you're going to be, well, in all cases, if you're pulling spreadsheets off of a website, it's probably good to always start with an original rather than picking something out of your files just in case there's been updates. And documentation, critical piece, as hopefully you've determined. And this list looks just like other lists you've seen. What were your data, your methods, your results? An assessment, you should talk about the sort of the scope and methods in your work, the tools you use, any particular caveats. I think that some sort of tabular summary of those high-level assumptions that really, set the direction of the analysis should be documented for sure. And then think about and compare and contrast the results.